All right, here we go. So we are going to be going over triangle congruence theorems. Um, so we're going to learn what they are, why they work, and how to use them. Before we start, does anybody know what congruence means? Raise your hand if you know what that means. Okay, nobody. Does anybody know what equal means? Okay, so two of you know what equal means. Oh, I see three of you. Okay, so okay, so all of you know what equal means, so that's a good thing. Congruence is very similar to being equal. If two things are, the only difference is when two things are equal, we're normally talking about numbers, like 5 is equal to 2 plus 3. We know the exact number and what it is. Congruence would be things that are more abstract, where we know that two things are the same measurement, but we don't know what the measurement is. A lot of time we talk about congruence when we're talking about lines or angles. Basically, it just means they have equal measurement, even if we don't know what the measurement is. Okay, does that make sense? Okay, good. So let's keep going through. We're going to talk about how to tell if triangles are the same as far as their measurement and their angles and everything, and ways to tell that they're the same. Okay. And depending on how far along you are in this course, you may or may not have started to do proofs yet. So before we talk about proofs in math, I want to get your guys' ideas about why you think proofs are important. So does anybody have ideas about why they think proofs are important? Raise your hand if you have something you want to add. All right. Okay. Nora, do you have a microphone? Okay, go ahead and type in whatever you want to. One reason why you think proofs might be important. Actually, I'm going to give you the ability to write, and you could just write it on here. Okay, I think you may have done this before, but if you look on your screen now, on the left-hand side, you should see a pencil. Click on that pencil, and you can hit the text button and write something on here, or you can use the pencil. If you click on the letter A, you can write text right on the screen. Okay, and Alina, I'm going to do the same for you, and you can write on there whatever you think, or a reason why you think proofs might be important. Alina, do you have a microphone? Okay, proofs help us understand. Okay, good. These are good examples that are directly related to math. Um, are there any other cases where we need proof for something that you guys can think of? Chemistry. Okay, good. What's an example of how you would use proofs in chemistry? Okay. Angela, you can go ahead and write on there whatever you think. Take measurements of liquids. Okay. All right. I went ahead and put that on there for you. Angel, what did you have to add? Or you can go ahead and write it on there. Or did you have a question? Okay. Well, we'll give you a minute to think of that. Now, from what I'm looking at, I think all your brains are so focused on school, which is a good thing. But I was thinking about good cases for politics. That's kind of something I was thinking, actually. Angel, is have any of you ever seen something like Law and Order, where you're in a courtroom and yeah, you have to prove a case. So somebody's saying that you're guilty of doing something wrong, and the world probably wouldn't work very well if everyone just believed what everyone said. When I say, suppose you cheated on an assignment, or you know anything like that, or committed a crime. If somebody's saying you stole something from a store, you need proof. You can't just start throwing out accusations everywhere. Um, so while it's important in math, it's also important in life. And so we're kind of learning skills to be able to justify our reasoning. Um, so all the stuff we're doing in math actually does translate to your life, even though you probably don't think of it that way now. You're learning those skills. So let's go ahead and move on. I want you all to go ahead and take this mini quiz. I know that you may not know many of these answers, and that's okay. We're just going to see what all of you think and what you do know right now, and then we'll review the answers again at the end of the lesson to see if you figure out what the correct answers are. So go ahead and take this mini quiz. You can select an answer, and then the blue arrows on the bottom will take you to the next question. So just answer each question, and then submit it when you answered all 5 questions. If you're having trouble doing the mini quiz, raise your hand. Hello? Can you hear me now? Okay, good. I think maybe it went out for a minute since 2 of you couldn't hear me. But just go ahead and take that mini quiz. You don't have to know the answers. If you don't know, just take a guess. And then we'll review the answers together. And hopefully by the end of the lesson, you'll know the correct answers to each question. And if you're having trouble taking the quiz, just raise your hand. All right. So it looks like everybody has put in their answers, and you all should be able to see the results. So the first to write a mathematical proof, we got 2 for Pythagoras, 2 for Euclid. And I actually asked the same questions as some of the other teachers here, and we got some similar answers. So I'll let you know what the correct answer is in a minute. When two segments or angles have the same marks on them, they are congruent, they are equal or parallel, they are congruent, and these are actually all correct. Parallel is a different kind of marking. You're actually going to have arrows on it, but you all got that one right on the money. Okay. How do you prove two polygons are congruent? By theorems and postulates. You measure the angles. Good. Same sum when you add them together. Okay. Use a theorem. All right. Nobody knows, but that's okay. So nobody knows the difference between SSA and SAS. Oh, wait, hold on. Oh, no, we got one of you does know the difference. And you're correct. It's side-side angle and side-angle-side. So we're going to, since we see the answer here, establish why it's important to say the difference between the two. And then difference between ASA and AAS. And one person notes the same idea, angle, side, angle, and angle, angle, side. All right, you guys did really well on that. Okay, so the first proof, the correct answer, is actually Thales. Okay, he was around before Euclid. And I'm not sure if he was around before or at the same time as Pythagoras. I think it was a little bit before him. But he was the first to write proofs like we see them today. Although Euclid is a little bit more well known for writing his own geometry system. But Thales did come before him. And Euclid expanded on some of the things that Thales did. Okay, so that's just a little bit of history for you. Okay, and then same markings. You guys all got that. Means congruent, equal, or parallel, depending on the type of markings. Okay. Okay, so now we're going to talk about SSS. Okay, so we kind of looked at before what SAS, SSA, ASA, and AAS means. Can anyone raise their hand and tell me what you think SSS means? Okay, Rory, you had your hand up. Go ahead and type in there what you think it means. Side, side, side. Good. Okay, so sides of what? Angela, can you let me know what sides of what? What are we talking about? Okay, sides of angles and shapes. What kind of shapes? Does anyone know what kind of shapes? Polygon. Yeah, we're talking about actually a specific polygon. Good, Nora, you got it. Triangles. Okay, specifically, we're talking about two triangles. SSS is the congruence theorem, which means exactly this, side, side, side. If the three sides are congruent, then that means that it looks like we got somebody joining us. Okay, if the three sides are congruent, that would mean that the triangles are congruent. Okay, so you guys should all be able to click on this button where it says Explore SSS. So go ahead and click on that. And This is something, it should work. Um, Raise your hand if you were able to open it and you see two triangles. Okay, and we'll give the other person a minute to get adjusted in here. Alright, go to the triangles. Now, if you see on the left-hand side, you should be able to move the shape and change the shape of the triangle. But no matter what you do, all the three sides are going to stay equal. Okay? So you can do it by pressing on the points on the left side, the triangle on the left side. Okay, and as you can see, the sides will change. And we can actually change the order of the sides if you click that button. So go ahead and play with these triangles and let me know if you can find two triangles where all the sides are congruent but the triangles aren't the same. So go ahead and try to do that, and if you're able to find one, then raise your hand. So you guys can go ahead and unraise your hand now, unless you're having trouble with the triangle program. Okay, so I'll give you guys 3 minutes to play with that, and then we'll see if anyone came up with something. All right, if we all can come back to here for a minute. Was anybody able to find two triangles that weren't the same? Okay, good. So everyone says no, and you shouldn't. As you can see, no matter what, when you move the sides of the triangle around, no matter what size each side is, the angles are going to stay the same. So that's the thing that tells us that the two triangles are congruent, is if all the sides and all the angles are the same, no matter what, how we move it, or whatever the case is. Okay? Now let's go on to the next page. We're going to talk about SAS and SSA. So who can tell me the difference between SAS and SSA? Angel, go ahead. Go ahead and write on here what you think the difference between the two is. Do you have writing access? Okay, guys, so we have side, angle, side, and side, side, angle. Now, can anyone raise their hand? Go ahead and put yours down, Angel. Can you tell me why the order is important? The order of the letters? If anyone knows, raise your hand. Okay, perfect. Okay, so basically both of these are cases where two sides and one angle is congruent. And two triangles. Okay, and the difference is the order of the sides and the angles that are congruent. So go ahead and click on the button that says SAS and SSA, and that should bring you to another page similar to the other one with two triangles. Once you have that page open and you see the two triangles, raise your hand. Okay, good. It looks like everyone has it open. You can put your hands down now. All right, now if you open to this, you'll see check boxes, one with SAS and one with SSA. The two red lines will stay congruent. The two blue lines will stay congruent to each other, and then the angle in green is going to stay congruent. On the left-hand side, you'll see a point that's in purple. You can actually move this point, and when it moves, the other one will make it so that those two sides and that one angle is going to stay congruent to it. Okay? And it's going to give you all the possible cases where this occurs. Okay? And then if you press the check on the SSA, so you can go ahead and check that off, you can do the same thing. You can move that purple point, and it will show you on the other triangle all the cases where that side is congruent. The angle on the left is congruent this time, instead of the one on the right in between the two sides, and that red one stays congruent. Okay, so go ahead and play with that for a couple minutes, and then we'll see if anyone could find two triangles that were not congruent. All right. Um, now that you guys have all played with that, raise your hand if you found two triangles that weren't congruent. Okay, nobody found any? Okay, so who's willing to explain to me what they saw when they were exploring the two types of uh, triangle congruence theorems? All right, Angel. Since I know you have a microphone, I'm going to go ahead and turn on your mic. Okay.
Can you hear me?
Yes, I can hear you.
Oh, good. What I saw was, like, when you put it at a certain angle, that you couldn't see where the congruence was, and it was weird. I thought it was weird when it was on the SSA.
Mm-hmm. So,
And,
what happened on the SSA?
like, I put it at this one point, and you could not see the second blue congruence line.
Okay, it like disappeared.
Yes.
Why do you think there was two lines on SSA instead of one?
Because it's to show what the possibility of the curve, how the angle is and the congruence.
Okay, good. Let's take a look at the everyone go ahead and go back over there. When you move it and you see the two triangles. Okay. Um, let's look at the one on the right. When there's two blue lines, on the one on top. Let's go ahead. Hold on. I'm going to take a screenshot so I can share it with you all. Okay. Give me just 1 second. Pause from computer. All right. And it's loading. All right. So this is what I have. And you all probably got something similar to this. Now, suppose that I covered this whole part up. Hold on, let me see. Make this a little bit thicker. Okay. All right, here we have two triangles with two sides that are congruent and one angle that is congruent. Do these triangles look congruent to you or the same? No. Does anyone think they look the same? No. Okay. All right, good. They shouldn't. No, everybody says no. Okay, so this is the reason, and what actually the second image is showing you is that there's two cases where you could have two sides that are the same and one angle, and there's two different types of triangles you could possibly have. Okay, and this is the second one, which is why we can't prove that when two sides and one angle are congruent, that the triangles are always congruent. Because they could be, but they might not be. Okay? And this is the reason why saying the order of the sides and angles is important. Because while SAS is a way to prove it, SSA is not a way to prove it because there's two possibilities. Okay? And we need there to be only one possibility for it to be something we can use to prove something. Okay, so this means that SSA, oh, oopsie, I didn't mean to erase that. Hold on. Okay, hold on. Let's just highlight this. I'll cross it out. SSA does not prove congruence in triangles. Okay, so only SAS is a theorem, and SSA is not. All right. So if you are doing this assignment, which many of you might be working on now, if you see something where the order is angle side side or side side angle, you can't prove anything. The angle has to be in between the two sides. Okay. Is that clear to anyone, or is anyone confused by that? Okay. Any questions about SAS and SSA? Okay. All right. So we are good on this one. Okay, now we have AAS and ASA. So by now I think many of you will probably know what this is, but can somebody raise their hand and let me know what AAS and ASA is? See somebody different. Anybody? All right, Nora, go ahead and write it out on there. What's AAS and what's ASA? Angle, angle, side. And one is angle, side, angle. Perfect. And these are in triangles. So both of these are theorems where there are two angles and one side congruent in two triangles. And this is the more specific. AAS is angle, angle, side, and ASA is angle, side, angle. So perfect. And this is actually one of the proofs that Thales did from the beginning of the lesson. So, do you guys think that both of these prove congruence in triangles? Is there anyone that doesn't think that?
You ran all that way for nothing because Brian is not even in here. That's this one, right here. He just walked that way, but I didn't.
We cannot be sure. Okay, so I guess we can find out. Go ahead and press on the button for ASA and AAS. You should see a page with two triangles like before. Once you have that open, go ahead and raise your hand once you see the two triangles. Okay. Okay, it looks like Angel's away for a moment, so we'll go ahead and move on, and she can catch up. Okay, just like before, you can move the purple point, and it will move the other side. The green angles are congruent to each other, the blue lines are congruent to each other, and the red angles are congruent to each other. As you can see, the angles kind of seem to be dependent on each other. So go ahead and play with that. First, you can look at ASA, where the two angles are on each side of the line. And then you can look at AAS, where it's the line and then one angle is away from the line. So experiment with those. Move the points around to see if you can find triangles that aren't congruent. And remember, just like before, if you find two that aren't congruent, the same thing will happen where you'll see two lines in one of the diagrams. So I'll give you guys a couple minutes to play with that and we'll see what you found.
Really should have seventh grade B, right? So the one that in seventh grade B that I was having a student problem is there's one.
Okay, we're back. Was Oh yeah, I wasn't talking. That's why. Can you hear me now?
Hi, my name is Brandon.
All right, sorry about that. Yeah, I put my microphone on mute for a second. Was anybody able to find two triangles that were not congruent? No. Okay, good. You showed it. There aren't. If you have two angles in one side that are congruent, the triangles will always be congruent no matter what the order is. Okay? We do have the two separate theorems, so whenever you're doing your work, you will have to know the difference between ASA and AAS. But you can say that if you have found two angles on one side that are congruent, that means the triangles themselves are also. Okay? So, good work on that one. Let's go ahead. Now, some more quiz or poll questions. Go ahead and answer this. This does not look like the correct image. Hold on. One second. Oh, we can use this one anyways. Go ahead and answer these two questions and let me know what you come up with. Okay, so we got one person with a yes, three people with a no, and then we got one for SSS, one for SAS, and one for SSA. Now I will tell you all that this is actually not the picture that was supposed to be here, so I'm not sure what I did, but I'm sorry about that. And the correct answer is actually no. They cannot be proven congruent because we have SSA. And SSA does not prove congruence. It's actually the only one that doesn't prove it from the things we went over today. Okay? So write that down in your notes that SSA is the only one that doesn't prove congruence. The rest of them do. There is one combination we didn't go over today, but we'll see if we can figure out what that one is at the end of the lesson. All right, let's do the next one. Okay, go ahead and tell me what you think of these two triangles. All right, so everybody got the first question right, which was yes, you can tell because we have two angles on one side. Two angles on one side always proves congruence. Okay. And then a couple of these are not quite right. We got one for SAS, one for two for ASA, and one for AAS. Okay, as you can see, this segment in between the two angles is the one marked congruent. So that means that S needs to be in between the two A's in our theorem. So this one is actually ASA. Okay. All right. Let's try one more. All right, go ahead and put in your answers for this one. All right, we have a perfect 4 for 4 on this one. Everyone got it. Yes, we can prove that these are congruent. And yes, it is AAS because the side is not in between the angles. So it's angle, angle, side. So good. It looks like we're all starting to get the hang of this thing. All right, now let's go back. This is the same questions that we answered in the beginning of the lesson. So go through it and see if you guys can get the right answers this time. Okay, looks like we got all 4 answers. Question 1, everybody got it. It's Thales. Good job. And question 2, everyone got it. Okay, question 3. All right, I would say that some answers are partially correct and some are fully correct. Okay. Um, One of them we said they're measures. While that's true, I think it needs to be more specific. Um, what do you mean about their measures? Are we saying the measures are congruent? Are we saying that they're different? Um, it's not clear from somebody who doesn't know what you're talking about. So that's one thing you definitely want to think of is who's ever reading your work, pretend that they don't know anything about math. So you have to really spell out every single little thing that you're trying to say. Even though I do know something about math, I want to see that you can explain yourself to somebody who doesn't. Okay, measure the angles. Good, but there's more than the angles we need. We need the angles and the sides. Okay, so if we can prove that the angles are congruent and the sides are congruent, that means that the 2 polygons are congruent. Okay, and then we have the same angles and sides. I think that's a very good answer. So that's basically what we're doing. We can use different words to say the same thing, but that's what we're doing. Theorems and postulates. This is true, but kind of like the first answer, it's not specific enough. What theorems, what postulates, how does it prove it? But overall, very good. We're all going to the same place here. So, like what I'm seeing. Okay. SSA is side angle. SAS is side angle side. That's what most of you put. All correct. One of you put an answer. I actually really like that. It says one you can prove congruence and one you can't. So all of these are correct, and one of you went a little bit further to explain why it's important to distinguish that difference. Okay, ASA. Okay, everyone seems to have gotten that one. Angle side angle and angle side. All right. So let's do one blank page. Okay, so everyone, we should have 4 things here. I want you all to write on the page one thing that you learned during this lesson. All right. Cool. And I think I got something for everyone, and I like what I'm seeing. How to prove something's congruent or not. Definitely something important in geometry. Um, SSA doesn't work. Good. And how to prove triangles are congruent. Um, One thing I want to add is triangles are kind of special in that we don't need to know all the sides and angles. Um, so in other figures, we may not need, or we actually do need to know every single side and every single angle to prove they're congruent. But triangles are, I guess, because they only have three sides and each side is dependent on the others. But other shapes, we will need to know all the information, whereas triangles are special. Okay. And then one more question. This is kind of for discussion. And specifically, this question is directed to when we have two angles and one side are congruent. Do you think it's important? Do you think the order of the sides and angles is important to mention? And there's no right answer to this, so just give your opinion, yes or no. And we'll kind of talk about why or why not. Okay. Okay, so Rory, you were the first one to say yes. So go ahead and, share with us why you think that.
Americans the year-long subscription ones. Americans more likely to be rich kids. Parents who are willing to put down, $1,000, $1,500 in advance.
Okay, good. Um, does anybody have something more important, more focused on why the order matters, though? Because the measures are important, I agree with you. But why does it matter, suppose, this is a really thick pencil, huh? ASA versus AAS. Why do you think the order of the letters is important? Or order of the angles and sides is important to prove congruence? All right. Okay, good. All right. Great answer, and I think everyone did really great today. It was good to see some faces, and I think that everyone seemed to take something away from the lesson today, so I'm really happy with that. I will send you all something. Give me a second, I'll stop.